I do know her name.
I'm going to say that when he starts
Shh.
to
That's not the first time I've done that. I apologize. Oh. Do you know how to use the alternative form of the derivative to come up with a formula for this derivative? Okay, do it.
Okay.
I'll do it while you do it. What's wrong?
Claire sneezed.
Oh, bless you. Right? What's wrong?
I messed up.
Yeah, let's review some things. Make sure you guys are good. This is the alternate form of the derivative, right? And now I'm just going to do is plug in f of x, f of 0, x, and 0 in the numerator and denominator respectively. When I plug in all these numbers, do the zeros actually do anything? You got to love the alternate version of the derivative. How do you work out x to the 1/3 over x to the 1? That's exactly right. The fraction bar is designed to look like a subtraction because that's what you do with the exponents. 1/3 minus 1 is negative 2/3.
Wait, so why do we plug in 0 for C?
Because what is it?
That's where I got messed up. It says x equals 0, but it's actually supposed to be c equals 0. I don't like it.
It's the same thing. They're just letters.
But x and c are different in the thing, but then it's using x, like...
In the formula, they are different. You're right.
Exactly.
But we are finding the slope of the tangent line at an x value of 0. I have multiple ways I can phrase that question, right? I can say find the tangent line at an x value of 0. That means A is 0 or C is 0, however you want to look at it. But you're not confined to certain letters, right? Like you get to use whatever letter you want. That doesn't feel like right. That does not feel. This is supposed to say 1 over 0. If I would have gotten 0 over 0, I would know that I need to do some manipulation. 1 over 0 is not do manipulation. That is it could be a vertical asymptote. In this case, it's vertical, just not an asymptote. Roger that? Well, and the slope of a vertical line is undefined because it's basically infinite. I got a question for you guys. Could you use the shortcut to tell me a formula for this derivative? We'll come back to differentiability. So the function is right here. Do you know how to write that as an exponent without a radical? This is x to the 1/3. And then how would you come up with a formula using the shortcut for this function? Take that 1/3. Right, that's what you would do. And this would be 1/3 x to the negative 2/3. And that, because the x is raised to the negative 2/3, I'd drop it to the bottom of that fraction where that 3 is. And it would look like this. Sorry for the scrunched up writing. Could you do that? Yeah, it's just the power rule. Same thing we've been doing. And then if I asked you to find f prime of 0, what would you do? What would you get? Which is still undefined. Roger that. Down the road, but just trying to this sucks, right? This sucks, but you're going to be asked to do a limit of a derivative. That's easy. I'm doing this, Miss Epperson, because we were talking about how eventually we're going to be calculating derivatives very fast. So it actually is pretty fast. But getting back to it. The fact that this derivative doesn't exist tells you that you have a vertical asymptote. Roger that? Yeah. Do we need to do another one? We got time?
7 minutes.
7? Oh, we got time.
You always think.
Well, I think it's 25, but it was 30.
Somebody's a
Who is that? Oh, that's the, yeah.
It's Officer Lane. You coming in, Officer Lane? Oh, just saying hello.
I did. You usually stand in the hallway when I go through.
Your daughter's something else now. I passed her in the hallway. Nothing. She didn't do
Okay.
anything. And I was like, hey, I know your mom. And she went, oh, okay. And she was nice. She
Yeah.
left off the weirdo part, but she clearly was thinking, this guy's some kind of weirdo. Man.
Maybe she's probably headed down to Andrew's probably. Is that where she's going?
She was definitely walking down the hallway this way. I don't know, but like she wasn't
She's
rude.
like, is that a good thing, bad thing? It's,
Oh, well, I
Maybe.
was like, you look just like her. And then she said, well, thank you very much.
oh, that's the first time she's taken that as a compliment. You just went, ooh.
See him, Officer Lane.
How old's her daughter?
Ninth grade, I think. If you see her, you'll know, like, she's got the blonde hair, the blue eyes. She's just a smaller version. I meant that. She's in the 9th grade, so everything about her is smaller than her mother. I was not trying to be rude to Officer Lane. Epson, you're kind of a pot stirrer, man. Jeez. We got time. We got time. What's happening to f prime of x as x approaches negative 2 from the left?
Goes to infinity.
What happens to f prime of x as x approaches negative 2 from the right? Careful, careful. Say it. I know what you're thinking. Say it.
Infinity.
I knew you were going to say it. You see it? You see it? Miss Hafer? Miss Hafer, you see it? You gave me the funny look. Is that right, Miss Harrell? It goes to negative infinity? Prez?
I think that's right.
All right, so I'm going to pick a point close to negative 2, but on the right side of negative 2. And I just want you to tell me the sign of the slope.
Negative.
And as I get closer to negative 2, still negative, but steeper, right? So it's a larger negative number, if you will. And as I get really close to negative 2, this tangent line is going to be nearly vertical, but it's approaching negative infinity. Oh. Is that the right formula for f prime? Let's see. If f of x is x plus 2 raised to the negative 2 power, what are you going to do with the negative 2? What's the new power? Which one? 1 or negative 3? With confidence. I like it. Negative 2 minus 1 is negative 3. Is that the same as that? Yeah, those are the same, right? Okay, so you already know how I found the derivative. So could you find, using that formula, the one that I pointed to, not the one that I wrote, f prime at negative 2? Without doing any work first, what does the answer have to be? What does that have to look like? Will it be 0 over 0? Can't be 0 over 0, because then I could do some manipulation to work that out.
A number over 0.
Thank you, Prez. And what is the number over 0?
Negative 2.
Negative 2 plus 2 is 0. Cubed is 0. That's how you would do the work. But this gives you... And because I have a number over 0, a non-zero number over 0, I know that I have some kind of vertical tangent line there. How much time we got? Last thing. Throughout the course of the course, there's going to be questions about a function being continuous and a function being differentiable. A function is continuous if it doesn't have any holes or vertical asymptotes. A function is differentiable if it has a derivative. If you're told that the function is differentiable, it automatically has to be continuous. We're finding, when we do a derivative, we're finding the slope at a point. If there's no point, you can't have a derivative. So just know that when you see in the instructions, this function is differentiable, you can assume it's continuous. Roger that? And then we'll pick up on this on, I don't know. Well, I'll see y'all tomorrow.